Hi everyone, in this video we are going to see solved gate question paper for the year 2023 and for the subject data structures and algorithms. In this part 1 video I am covering two questions. Let me go to the question number 1. So question number 1, which one of the following sequence when stored in an array at location A1 to A10 forms a maximum heap tree? So four options are given. In this, which option forms the actual max heap tree? This is the question. So let me tell the answer is option B and let me explain how it is. Based on that we can check the other options also. So for a maximum heap tree it has to satisfy two conditions. One, root node is greater than the children node and it should be a complete binary tree. Let's take option B. Here 23. Let's take it is the first will be the root node and below that we will be having 17 and 14 and below 17 it is 7 and 13 and below 14 it is 10 and 1. Again below 7 it is 5 and 6 and below 13 it is 12. So let's check it is a maximum heap tree. For a maximum heap tree, root node is greater than the children. In each node, root node is greater than the children node. It satisfies the first condition. Then it forms a binary tree. For a binary tree, it should have at most two children. In each node, it have at most two children. So it satisfies the second condition. So this is a maximum heap tree. Option B is the answer. Why other options will not come? Let me tell you. So in option A, below 23 it will be 17 and 10. Below 17 it is 6 and 13 and below 10 it is 14. So 10 is smaller than 14. Root node 10 is smaller than its child node. It is not a maximum heap tree. In option C, below 23 it is 17 and 14. Below 17 it is 6 and 13 and below 14 it is 10 and 1. Below 6, 5 and 7 and below 13 it is 15. 13 is smaller than 15. It's not a maximum heap tree. Let it be a little bit confusing. Once you draw the tree, as I said, you will be clearly see these root nodes are smaller than their children node. And for option D, below 23 it is 14 and 17, below 14 it is 1 and 10, below 17 it is 13 and 16 and below 1 it is 12. Obviously, the root node is smaller than the children node and it is not a maximum heap tree. So answer is option B. It's a simple, easy and direct question. Once you draw the diagram as for option B, for the other options also, you can clearly find answer B only forms the maximum heap tree. Others are having the root nodes smaller than the children node and so they are not the maximum heap tree. It is the one more question asked in 2023 gate questions, easiest one. Let's move to next question. Here, let SLLDEL be a function that deletes a node in a single linked list given a pointer to the node and pointer to the head of the list. Similarly, let DLL delete be another function that deletes a node in a double linked list given a pointer to the node and pointer to the head of the list. And let n denote the number of nodes in each of the linked list. Which one of the following choices is true about worst case time complexity of SLLDEL and DLLDEL? So we have two functions in single linked list delete function and double linked list delete function. We have to find the worst case time complexity. It is also a direct question. Let me tell you how it works. In a single linked list, we have to delete a node P. So in a single linked list, each node will have a pointer that points to the address of its next node. So if we have to delete a node P, what we have to do? We have to find its previous node and it will have a pointer that points to the node P. We have to change it into the pointer pointing to the node next to node P and then we have to delete P. So what if temp of next of data is equal to P data? We have to change P next is equal to temp next is equal to P next and then free P. So we have to find the previous node of that deleting node and we have to change the pointer that pointing to P as P next and then we delete P. These are the steps taken in single linked list for deleting a node. So in worst case, we have to find the worst case complexity. In worst case, to delete a node, there is a possibility that we have to travel all through the list to find the previous node of that node. So we have to travel the entire list. So the steps taken is n. So here in single linked list for delete function, we will be having O of n as time complexity for worst case. Next, in double linked list, each node will have two pointers, one pointing to its previous node and another one pointing to its next node. Here also let's take this P node. We have to delete it. What we will do? We will check its previous node. It is pointed by this node itself. So we go to the previous node. We change its pointer, that pointing to the next node, as P next. And we have to go to the next node. That also that next node of P is also denoted by its pointer. So P will have two pointers, one pointing to its previous node. By that we will go to the previous node and we will change its pointer of next node and change it. Then we come to P, we will find its next node, that is pointed by its pointer, and we move to the next node of P, we will change its previous node, previous pointer that pointing to previous node as P previous, and then we delete P. So P previous next is changed to P next, P next previous is changed to P previous, and then we delete P. This is the action taken place for double linked list delete function. So here each cell will have a two pointers pointing to both of its previous node and next node. So if we want to delete a cell, we also need its previous node and next node. So for any cell, we can find its previous node and next node in single step just by finding that P, that deleting node P. Just it is in that node itself. So we will be having only one step. In any worst case also it will be one only. So the worst case complexity for double linked list delete function is O of 1. Answer is O of n for single linked list delete function and O of 1 for double linked list delete function. Option D. So it is very clear, direct and easy question also. We just have to check the process, how it works. And these are the two questions that is covered in this video, and we will be covering the other questions in my next video. Please subscribe for other GATE questions, solved questions for GATE 2023 question paper. Thank you for watching this video.